Hello and welcome to this new tutorial, and in this tutorial we are going to learn how we can do object detection using Yolo3. So let's get started. Since I'm going to use a pre-trained model for object detection, so first of all I need to go and download the required files. So you can write darknet and press enter, and this is the link where you need to go. I will also provide it in the description, and from here we can go to YOLO real-time object detection, and here is a link for a pre-trained weights for the Yolo3, or you can also click on this, copy this and paste it here, and it will start downloading the weights of the model, pre-trained model. And also we need two more files. So what I will do, actually, maybe we can go to the GitHub repository of the author, and we need the configuration file, so we can go to the configuration, and since I'm using the Yolo3, so I am going to download this Yolo3.CFG file, and we can open it as raw and simply click on it, and in the downloads I just save it as text. And another file that I need is, since I'm applying the object detection, so I need the labels for the objects on which it is trained, and we can go to the data, and inside data there is a Coco Names file, so you need to click on that. There are, I think, 80 classes in it, so 80 lines, it means 80 different classes. These are the classes which we can detect using Yolo3. So I'm also going to save it as a text. Okay, so the download is completed, and these are downloaded here, and let me remove the extension text from it and keep as it is so that it becomes easier for me to read. Okay, yes, and I will copy these into some folder because I frequently delete files from the download folder. I have an OpenCV folder, and inside it I'm going to create a new folder. I call it Yolo3, and I will put these three files which I need for using the pre-trained Yolo3 object. So let's go and write a code to read these three files first. So I have already configured this project, which uses EmguCV 4.4, and under this DNN I'm just going to add a new menu item, and let's say call it Yolo3 object detection. And first I will do a load model, and then we will do a test model, for example. So when I double click on this load model, and I will write a try catch, and of course I want to load all those three files, and I will read them into a net object which is present in the OpenCV.Dnn module, deep neural network module. So maybe I can create a global object over here, and let's say this is for Yolo3, so that later I should not forget it. And the first thing that I need to do is using Emgu.CV.Dnn. So this is the deep neural network module which I will be using, and inside it there is a class called net, and let me call it model, and I initialize it with a null. And another thing that I need is a list, maybe of strings. Let me say class labels is equal to, let me set it to null also. So I have defined the model, and now I will ask the user to select those files, three files. So dialog is equal to new dialog, and we can say dialog dot multi-select is equal to true. So once he will select all those files and we will load them. Once we load the model, we don't need to reload it again and again. So if dialog dot show dialog will show the dialog, and if the result of the dialog is okay, which means that the user has selected some file, then we can read those files. So since there are multiple files, we need to separate those files. Maybe I can use the extension, for example, name, CFG, weights, and then read them separately. So I'll be using a link queue here. So path for the weights, let me call it path of WEIGS is equal to dialog result, dialog dot file names, because we have more than one file expecting to select it, dot where we can put a condition here if x dot ends with. So I am looking at a file that ends with this one. Make sure that the file extension is small, or we can do something. If the extension doesn't matter, we can do dot to lower first and then dot ends with. So I'm going to select the weights file, and there should be only first, so I'm just selecting one file to make sure. Okay, we can do the same thing for the other two also. Path for, let me say this config, and what is the path? I'm selecting the path for the classes, and here for the configuration file the extension is CFG, and also for the labels it is the names extension. So once we select the appropriate paths for weight config and the class labels, we can go ahead and create the model object. So to do that, we will use DnnInvoke.download the darknet. So we will be using readnet from darknet. And here we have the second overloaded constructor, which is expecting a CFG configuration file. So I will provide path config. And also if we have the pre-trained model, we have already, so the weights that we are going to pass. So this one will read the pre-trained model according to the architecture and the weights already provided. And also we will read the labels into this class labels is equal to, I'll be using file dot read all lines, and the lines that we are going to read from the file is provided in path classes, and we can convert it into a to list, and that's it. And optionally we can give a status lbl status.text model loaded. Okay, so this just loaded the required files, the model and the class labels, and now we can go ahead and test the model on some test image. So double click on this test model, and I will be writing try catch. The first condition I will check here is whether my model is null. If it is null, it means we cannot do anything. So let me throw an exception saying that load the model. Okay, so since I throw the exception, it will directly jump into the cage, so I don't need to write a return or something else. And now for the model, we need some parameters, some threshold values, and I will explain them gradually. And the YOLO model can process at different sizes of the images, 608, 416, or even a smaller size, I don't remember actually. So we will set those, what size of the image that we will provide it to it, and some other threshold values. I will explain them later. So the first thing that we will do is the confidence threshold. That what should be the minimum confidence to consider it as one class. For example, I say that 80% confidence, 0.8, it is a float. So another variable or the threshold that we need is non-maximum suppression threshold. So if two rectangles are so close to each other, so how we can combine them? So I just say that 0.4, and I just want to consider the image default size to be, let's say, 416. As I said, we will fix the size. You can change it. There is also for efficiency 608 and 300 something also. Now it's time to read an image and pass it YOLO model. So I just want to create an image and let me call it PGR. Depth is in bytes and let it be equal to null. And I don't want to fix it. I would like to ask the user to basically select an image. So the best option could be to use a dialog. So is equal to new dialog. And if you want, we can provide some filters also to make sure that only images are being selected. So images, image files, I can say, and we can show it to the user. Let's say JPG star dot png and many more if you want to add it here, and then put a pipe, and this is the exact extension it will be filtering out. And we can show the dialog to the user, show dialog, and this one is equal to dialog result.ok, which means that the user has selected an image. Then we can create this object is equal to new and the dialog dot file name, since we are expecting only one image file. And by the way, instead of just putting it, we can do something like, as I said, we can resize it. So that is the best option here. And we can give it a size, as you can see here, what should be the width and what should be the height. So I can use this image default size width and default size as the height, and what kind of interpolation that we want to use, .Cubic for better performance. So we read the image that we want to test it and resize it according to our needs and set it over here. Okay, great. And the darknet is expecting a tensor from us. So we need to convert this image into a tensor form. So what I will do is variable input, we can call it like this, DnnInvoke.BlobFromImage. There is a method which basically will take an image as an input and it will convert it into a tensor in such a dimension that is acceptable by the model. So the first thing is the image that we want to convert it into a tensor. The second thing is giving us, do you want to scale it? Normally the authors recommend it to scale the values like this. So I'm just scaling them by multiplying with 1 divided by 255 so that they will be between 0 and 1. And here it is asking for the default size if we want. I already did the default size over there, but if you want we can do it here. But one of the most important parameter is here, swap B, R, and B, because you know our we read it, the sequence of the channel is blue, green, and red, but the tensor is expecting an RGB. So what I will do here is swap RGB is to be true. So we want to swap them so that that is suitable for reading it into our darknet model. And that's it. And now we can tell the model. Here we just load the model previously, and now we will set the input for the model. So what we can do is model.setInput is the input that we will take it now. This will be the input that will be passed from the input layer to the output layer. And the second thing I can write is model dot set the preferred backend, which one as a backend we want to use. Is since I'm using the OpenCV, and I think the default is also the OpenCV, I'm not sure. Okay, default's equal to interface engine if OpenCV is built with Intel's. Okay, to make sure I'm using OpenCV as backend, and the model dot set preferred target, that if you have the GPUs then or others things OpenCL, whichever you can use, select CUDA or whichever target you want. Right now I have CPU. So these are the, now it's time to pass the input through all the layers of the model and get the output. So we can get the output in a vector of mate. So let me call it a vector of mate is equal to new vector of mate. And this I created to store the outputs, and the outputs will be in the form of a mate object. And there will be more than one mate object because if you look at the architecture of the YOLO3, it basically has 3 output layers. So all those 3, for each layer we want to get the output and put it in this vector of mates. So more than one mate will be there. And now to pass the input, we will use the forward method. And here what we can use is there are overloaded constructors, so you can obtain the outputs as vector of mates, and also you can obtain the outputs for which layers you want to get the outputs. We can specify them. So what I will do here is I want the output to be in vector of mates. And the second thing, which outputs names of the layers. And of course, I need the outputs of the last layers. And as I said, there are 3 layers which basically which are the output layers. So how we can obtain those? We don't know their names. So there is an easy way to do that. So we can say model dot unconnected layer names. That's it. So it will return basically a string array which contains the names of the layers. So this is how we will get output from the output layers, and it will put in the vector of mates. And that's it. So the model, this YOLO has produced the outputs and it has given to us. Now the post-processing is the most difficult part in my opinion here. So we need to do the post-processing to see what is the output, what was the bounding box, where is the bounding box, how we can calculate the score, and what are the indices of those scores. And by the way, if you read the YOLO, there are 80 classes, so there will be 80 vectors for each class. What is the probability that this object belongs to which class? So there will be the probabilities, 80 different probabilities, plus the information about the bounding box, the x, y coordinates of the bounding box, the width and the height of the bounding box, and there is also a confidence score as well. So for each bounding box or for the prediction, there will be 85 different values. So we need to do a post-processing here, guys, which is the most difficult part of it, I guess. Post-processing. We can obtain a vector of rectangles, and we can call them bounding boxes. So we need the bounding boxes to draw the bounding boxes around the detected objects. We need a vector of floats for the scores that we have obtained. What was the score for each class? And we also need a vector of integers basically, and this is we need the indices. We call it indices for each class, which ones to retain, which ones to remove. So we will keep that information in these indices. We will see it now. So what we will do is how many outputs we have to loop through all those outputs. So output matrices, I will run a loop. So integer, let's say k is equal to 0, and it is less than k dot vector dot size. So we will process all the output layers that we obtained, and let me call it a mate is equal to vector of mate, and I'm working on one made object at a time. So what is one output that I have obtained? And the next thing, to be easier and to work more conveniently, I can convert this mate into a list of 2D list of floats maybe. So what I will do here is public static list of float arrays. I will return into, and I call it array d list, let's say 2D list, something like that. And we will take an array as an object, let's say array. This is just, I want to make things easier for processing, that's why I'm doing this. Integer rows, how many rows do we have? We can obtain it by calling this array.getLength, 0th dimension, and the rows we can obtain them by calling this .getLength, first dimension. So these are the number of columns in fact. So once we know the rows and the columns, let me create another float array and call it the list is equal to new float array list. Another thing to output or to keep the information temporarily, I also need the float, and we call it temp new list. Okay, and I can create, basically now I know the rows and the columns, I can create a float to the array data. I don't think I don't need it actually. I don't need it. Okay, and now I can loop through for integer I is equal to number of rows we have, and I can set this one clear it temp.clear, and for integer j, and j is less than number of columns, we can do something like this temp.add and float dot parse array dot get value, which value we want, I comma j, this value, and dot to string, and that's it. So we read all the columns and then add this one into the temp. I think I missed one of the brackets here. Okay, once we read that, we can add into the list add, and we can add this temp to array. Okay, and once we finish that, we can return the list. Okay, so we get an array and we get the list of that float arrays, and that will become a little easier for me to work back here. So what I will do is variable data is equal to helper class dot array to 2D list, and we are expecting this made dot get data. Okay, and now I can loop through all the data. We need to look for each column and each data over here and check its score, and if it is greater than, let's say, the confidence score, then we will consider it for further processing, otherwise we will reject it. So for integer ji and I is less than data dot count, and now let's read row by row. So for each row, as I said, for each instance, we have 85 different values. So we will be checking those 85 values. So how we will do that is we are getting the data of ith. Okay, we get the ith row because in the list, this is a list of row arrays. So I get the first row. Okay, so in each row there are, as I said, 80 classes. For each class we have the score, and the first five is are different: x, y, location, the center, x and y, the width and height, and a confidence score, which we don't need it. So I will skip those first uh, five values, and we will be looking on the last 80 values. For each class we will see which one has the maximum confidence for it. So the first thing that I will do is variable row scores. Let me call it scores is equal to, from this row I want to skip first five. I don't need to process them. Dot to array, let's say. Okay, and now I want to find that from these row score which class has the highest confidence or the highest score for which class I want to find out. So let me call it class ID is equal to row scores dot to list. Let's say it will be easy for me to, sometimes I am doing into the list and sometimes into this. So index of row scores dot maximum value. So what I'm doing, whichever the index I have the maximum value, I just want to find out that index. So that will basically give me the class ID. So the index is basically the class ID because from 0, they start from 0, 1, 2 up to 79. So once I find the class ID and I want to find out what is the confidence score for that class, confidence is equal to row scores of whichever the class ID I have obtained. I just want to find out. For that class, since I find the index, that is the class ID, so label you can say. And using that label, since it is an array, so from that array I find out what is the confidence score. Now we can put a condition on this confidence score for a particular class. For example, if it is a bird, so if it is a bird, so that is the class ID. I want to find out what is the confidence of labeling it or considering it as a bird. So if this threshold value, if this confidence is greater than the minimum confidence threshold that we have already defined, what was that name? Confidence thresholds. Confidence threshold, if it is greater than, it means that it is certain about calling this one as the bird or a certain class. So now we will be using the first four values, or the first five values present in it, to find out the left top corner of the bounding box and the width of the bounding box. So what we will do, variable center underscore x, basically it gives us the center of the bounding box. So we need to do one thing here. Row of 0, the first is the x value in our each row, we will multiply with the image dot width, so that it will give us the x, center x. But in fact I can convert not a float, we can convert it into an integer. So we multiplied the whatever the value we had and with the width of the image to find out the actually the center value of the x. So these are written in such a way that we need to multiply with this one. Actually we are using this information, it is not exactly the center, so to find it we multiply with the width to get it, this x. And similarly we can do the center y by multiplying with the yx, the next value, which is y, with the height of the bounding of the image. Similarly, we can do for the width and the height in the same way. So what we will do, the row's second value or and the third value will be multiplied in the similar fashion. So this one will give us the width of the bounding box, and then this one will give us the height of the bounding. And since this is the center of the bounding box, we don't need the center, although the width and height are okay. We want the point to be the top left corner of the bounding box and width and height so that we can draw it. But this way we find the center of the x. So what I will do, if we know the center, if we know the width and the height, what we will do is variable x is equal to center of x minus, we can divide this width by 2 divided by 2, so that when we subtract it, it will go back, and actually it will give us the top left corner. So I can convert it into an integer also. So this way we calculated the exact x coordinate or the starting x point of the bounding box. Similarly, I will do for the y. So we say y, and here instead we will be using the y, and of course we will be using the height. Okay, so once we find the xy, we know the width and the height, then we can create a rectangle, store that rectangle information, or the bounding box, which we call. So b box, as you know, I created a vector of b boxes. So we have the vector of b boxes dot push, and we can create a new rectangle, okay, and this new rectangle, it should be like this, I believe, or is it expecting, you can see that it is expecting an array of rectangles. So let me do something like this, although we don't have array, so I will create an array with one element only, new rectangle. So we know the x, we know the y, we know the width, we know the height, and that's it. So we just created the bounding box for that class, and we also need the scores and the indices. Okay, so what I will do is indices dot push, and this one also needs an integer array, so we can create a class id, that is. So this is the class we have, and also scores dot push, and for the scores what we need is the new float array, and we can give the confidences. Okay, so that is it. So it will loop through all the outputs that we have for each layer, and then we are searching it and filtering out. So we are selecting the high confidence scores for each class. So in an object, there may be more than one object and different types of objects in it. So we obtain their bounding boxes, what were their labels, class ID or the labels we can say, and what was their score we stored in it. So the problem is not over yet, because in one location we can have multiple bounding boxes for the same object. So we should not display basically multiple bounding boxes for the same object. So what we can do, here comes basically the non-max suppression algorithm, which we will provide all these scores with the minimum threshold and a non-max suppression threshold and all these values. So it will give us only the bounding boxes that are unique, and the closest bounding boxes, it will suppress them out. So what we will do is variable idx, I create a new indices. So this will be the indexes of the new labels only, which it will contain, and I will call this DnnNMSBox, non-maximum suppression of the bounding boxes. So it will return an integer array, which basically consists of indexes of the final labels. Those are retained. Okay, and here we can use it like b boxes dot to array. There are two basically options available, whichever you want. Maybe we can use it like this, or maybe we can directly pass the bounding boxes to them also, whichever you want. And the second is the scores, so scores.toArray. Okay, and the third parameter is the score threshold. As we know, we have a confidence threshold, and it will use this confidence. So NMX threshold also we have defined it previously on top. So this one will give us only the IDs. For example, if the bounding boxes are overlapping in one location too much, so it will give only one ID, considering it as one class. So we want to show those classes only. So I want to create an output image. Let's say output is equal to Emg.clone, let's say, or maybe copy default, or should I? Okay, just let me clone it. Doesn't matter. Or even we can show on that, even doesn't matter. So I want to display all those bounding boxes which have been filtered out. So we can go through a loop idx.length, and we will get the indexes. Let's say index is equal to idx, whichever the label we have received, or the index. Okay, and the bounding box that we have here, bbox is equal to bboxes. Inside from the bbox we have, for this index or for this label, give us the bounding box from our all bounding boxes, and we can just draw it. Img output dot draw, and here it is expecting the what is the, we can provide bbox. So this is what we will draw it, and then it is expecting a color, new color. We can give it a bgr, let's say, or maybe b green, r is 0, and the thickness is 1. So I draw the bounding box for that label, and we can also optionally put the text. What is the label actually? CvInvoke.PutText img output, and what is the class labels? The class labels are present here, and we need to find out which label from indices using this index. So give us the exact value of the index from the indices, and then it will display it. I think we can, here the next is the point, where should we want to display it. Basically bbox, we can do it something like that, dot x near to the x, and bbox dot y, and to push it a little bit downwards I will add a 20, for example, just to show the text. Next, the font face, font face dot, we can use the simplex or a plain, it doesn't matter. And if you want to scale it, let's say I just don't want to scale it, and what should be the color of the text? So color can be a red color, let's say bgr 255, and if you want we can provide a thickness of 2. So we loop through all the labels that have been filtered out, and we display them on this img output, and now we can show it in a picture box. So image is equal to input is bitmap. Okay, that looks fine. Oh, there is one thing that makes sure this is wrong. I think it should be like this one. So we should multiply first, and then we should actually convert it into an integer. So here also. Okay, this one is the same here. Okay. Let us see the results first, and then we will come back and look at the code in a little detail by debugging it. Okay, let me start. So the first thing that we should do is to load the models. So the model that I have with their class labels and a configuration is over there. So the model is loaded, and now test the model. And let's try with the dog image, and it is processing, so it will take a little bit time. Okay, so you can see that it has given us two bounding boxes. Both are dogs, and it is working perfect. So let me test with another image of, let's say there's an aeroplane. So yes, this one tells us this is aeroplane. Okay, and let's try with a human, for example. Okay, a person, and again there is Messi's picture. So let's give him this picture. Looks fine that, and this is what it also find that there is a sports ball also. That is very good, but remember that it will not always work. Its accuracy is, I think, 53%. So when I give an image like this, let's see, now you can see there is for ambulance or something, it didn't produce anything. So but overall, again, for this one, it didn't produce any label for it. So but it is very strong algorithm which has been trained. The one thing that I just want to show you, let me put a breakpoint here for non-maximum suppression algorithm, and let's see what happens behind the scene when I click on the test model. And let's say I selected this dog. So how many bounding boxes this one is returning. So let's see that we are given different bounding boxes and we apply the threshold, and when we look at the bounding boxes, you can see it has returned 10 bounding boxes. So these are all the potential candidates. It's think that it drawn different bounding boxes around those two objects. So but we don't want to show all these 10 bounding boxes. And also if you look at the indices or the class labels, in all of these it thinks that it is the 16. I think 16 is the dog which I have shown you. And for 10 bounding boxes and their label, it thinks. And let's look at the score. I put a high confidence, so you can see that 97%, 99%, 90%, 96% it is sure that it is belongs to the class label 16, whichever the label it is. We already read it and we will display. Now of course we don't need all those bounding boxes. Of course there are only two dogs we have seen as objects in our case. So this is what our NMS algorithm will help us. So we provided the threshold, we have provided the confidence threshold, and then using the boxes and the scores, it tries to merge the bounding boxes which are around the same object. And now if you see here, when I press F10, and it says only two bounding boxes are returned at index 6 and index 1. But we know that whether it is index number 6 or whether it is index number 1, and this give us index number 6 which is also label 16, next one which is also label 16. So if there are different objects, of course their labels may be different, but it says just keep this one, and that's it. So we retain two bounding boxes and we draw those two bounding boxes and we show it on our image. Let's try with some different objects. If I have, let's say these are all sheeps. I don't have a mix. Now, for example, in the case of Messi, we see that there could have been two objects. And in that case, if we look at that, what does this one do? In case of Messi, there should be two different labels. And let's see what it returns for us. So now look at this. In the indices array, we have 11, and these are all whatever the label it looks. The 0 label is, I think, for the person, the first one, and then there are 32, 32. This may be a ball object, so sports ball object. And now when we pass it all those, so it just returned two objects. one is on the 5th index and one is on the 8th index. So when we look at the 5th, so this is 0 and 8, then this says just keep these two, and then we draw them out, and here it is the final result. So YOLO is already, is a very popular object detection algorithm which has shown prominent results, and we just use a pre-trained model in this tutorial, and we try to learn how we can use it in EmguCV. Okay, then hope to see you in another video.